Right, today I will talk about the Higgs mechanism in the standard model. We already saw some spontaneous matrix Vikings with the examples of the scalar fields and the complex scalar fields as U1 symmetries and the gauge boson fields in the U1 covariance derivatives. And today I will talk about how the gauge bosons and the fermions acquires some of the mass with the coupling of the Higgs. And in standard model, the gauge matrix are given by the U1 summed as U twos and there are additional SS3, but I don't want to talk about some SS3 gauge symmetries for the QCD because the gluon don't have the mass. So I will talk about this mass of the double and the jet boson and the mass loss properties of the photon. So such a U1 sums and SS2 symmetries electroweak factors gauge symmetry, and there are some labs on this chiral symmetry for that SS2, which is only left hand is the side of the double knot. So Higgs piece can be constructed with the double knot to satisfy the aesthetic symmetry. So a purpose is defined by the charges scalar fields as a complex scalar fields and lower ones that are towards complex scalar fields. So there are two complex scalar fields that are the Higgs double knot. And then we can construct the Lagrangians, but that is color piece pi, and this given like that. And such kinetic terms can be written by the covariance derivatives of the U1 symmetry and the SC2 symmetry. And the potential terms are very similar forms to with the spontaneous symmetry breaking already we discussed, and we can bound some of the minimums, the one the such a mu scales negatives, then the minimum substantials are given like that, non-zero 6 vacuum excitation values, and we can choose that the neutral complex piece, such the real part of the neutral scalar piece equal to the vacuum expectation values as choosing of the specific vacuums, and we will give some real Higgs field H. And the other some small perturbation fields, like the Goldstone boson fields, is eaten by the some gauge boson field that we mentioned in the previous videos. Some of the choosing of the specific gauges freedom. Yes, already Goldstone boson fields that are already gauging away. If we choose some specific gauge, then we can remove the Goldstone field in the Lagrangian. And the kinetic term, the mu pi, the covariant derivation contains some real algebra generator, which is some of the charge and some of the gauge both of gauge boson fields, and either act on the such as color field. And we can expand this in this formulas in the 2IT matrix, which is the last Higgs fields, and some of the Pauli matrix sigma acts on the such as W3, W2, and W1s. As a SAT symmetry. And if we calculate the each learning columns and is given like that, there are some of the vacuum expectation values and the non-zero vacuum expectation values on Higgs field, and it will be couplings to the such a B bosons through W boson. B bosons correspond to the U1 symmetry, and the W's back to bosons such W1, W3 is corresponding to the SAT symmetry. And also there are some non-zero vacuum expectation values will give there some massive sample that gauge bosons. And there will be the mixings of the such as U1 and SAT gas symmetry. So there is some kind of term of the Higgs fields. We can define the W plus minus bosons as linear combinations of W1 and W2, and there's like canonical conjugates. So if we rearrange the method of the previous formula, then we can define the massive system of the W's bosons with the Hermitian conjugate term. So there are also 1 over the 8 with Kiss, which is non-zero vacuum expectation values of Higgs, and the coupling constant Z will give the mass of the gauge bosons such as W's charged with current. So mass of W boson is given by the 1/2 G times V, such as G is coupling constant for the SC2 case. So such a mass of the W bosons are determined of the SU2 coupling constant and the non-zero vacuum expectation values of the Higgs. And so similarly, we can define of some jet bosons and the photons, I mu, and that is the mixing of the B bosons and the W3 bosons with the Y begins the mixing angles. And if we define like that, then there are some massive tempo jet boson, which is exchanging schedules for the neutrals weak current, and it is determined by the also non-zero vacuum expectation values of Higgs and the coupling constants of the U1 and ST2. And there are no massive terms of the photons. One half of the Riemann and which terms there are no such terms, so mass of the photons with the zeros. And such wide-bigger angles can be defined as some YTO sort of some coupling constants of the U1s and SU2 symmetries as G primes is the U1s coupling constants and the G's the SU2 coupling constants, and the ratio sort of that is defined as a tangent set as W's, and in the geometric point of view, it seems like that. There's Z and the G prime, and the set of W's, Y mixed angles, or electroweak mixing angles are defined like that. And we can find the varieties of the mass of the W boson and Z bosons as is Weinberg angles cosine theta W. So this occurring mass of W and Z bosons they cause the glaciers Weinberg models, so called GWS model. So that's how the gauge boson occur the mass by the mixing of the electrons and the weak structure. And also already we mentioned the spontaneous matter Viking in the previous video. Some chiral mass is some one widget of the Higgs mechanism, but another widget is some couplings between the Higgs and the gauge boson field. So such a chiral mass is coming from the non-zero spectrum expectation values of the Higgs field, but there will be additional Higgs field H, which is some of the small perturbation from the such a non-zero vacuum expectation value, and there will be some coupling between the W boson and the Higgs and the Z boson and the Higgs. And such a coupling constant is determined by the some coupling constants of the Z W and Z and the mass of the W and Z boson, and there are some triple vertex, quadruple vertex, and some one Higgs and the two Z bosons vertex that is possible. And such as the vertex is very important for the binding of the Higgs, the production and the decay process. And additionally, there are some of the specific parameters of the coupling constant, such as SU2 coupling constant is equal to the W's coupling constant, and the jet bosons, such a neutral current coupling constants can be defined like that, G keys and G prime keys. And there are additional parameters. We know that there are some G and G primes, and there's some coefficient from the potentials to be found, such as mu and lambdas, and the vacuum expectation values can be plotted by the such coefficients. So there are some parameters, and we can find the vacuum expectation values. Yes, only going. Maybe there are some problems in here. Yeah, just keep going. Yeah. So we can determine the vacuum expectation values by some experimental observations of the W strange boson mass. Maybe I think it's enough. Maybe there's some explanation of the course interactions that will be maybe the I will explain about the tomorrow's sessions, and the point is the gauge bosons occur the mass by the non-zero vacuum expectation values, and there will be some of the couplings between the Higgs fields and the gauge bosons in the standard model.